even is happening here? Let me just put this aside. Yeah, I think it's okay now. This should work. Hello. There we go. Can I hide this? I don't really need this. Oh yeah, it actually is examination for tomorrow technically. So I have a qualifying examination tomorrow for an internship, and so we need to practice Python fundamentals, and that's what I'm trying to do. Getting used to Python again after some time or some break. I've managed to do this yesterday for an hour. I think we'll be moving now to two pointers. We'll try if we can remember how to be efficient with it. So I guess let's just jump right into it. I need some music. Wait. I don't care if it gets copyright strike. Just need to practice things. Okay. Let me just lower that. Might be too overwhelming. Alright, I think we're good to go. We'll do the move zeros first, then is subsequence. We'll start the timer for this as well. But more importantly, just get started. Okay, reset the timer. Started. Move zeros, easy. Given integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Okay, so we need to be very space conservative here. This is technically swapping things up. Huh. Okay. So my first thought here would be to parse through the list, for example 0, 1, 0, 3, 12, and once you see a value that isn't 0, you just put it in the first index, then the second index, then to the third index. And the only thing to keep in mind is that once you do that, you need to make them 0 along the way as well, right? So I'll just make a variable, we call it count, and the count will just serve as an iterator throughout the thing that we're having here. So I'll be initializing a for loop to loop through the array for I in a range of the length of the nums list. So the case here would be that if nums I is not equal to 0, what I'll be doing is that nums count, which is initialized on the start, would be the value of the I would be taking the value that is not 0. So we'll be moving that up. Then the one that we've just moved will make it 0. And I'll just increase it by 1. Then I think this is already good, isn't it? Yeah, this should be good already. This is very limited already because you're doing it on n time. Time complexity is just O of n. That's the worst case, right? Just need to iterate through all of it. And the best case would be also O of n, because theta of n, because you still need to iterate through all of it. We don't really have a condition to check to check if there's any remaining ones there. Wait. So when once you get one, you output 0. Oh, okay. Wait. That is a problem. If they're not the same, right? If I is not equal to count, then we'll be doing that. Regardless, if not, then it's fine. I think that's an okay condition to add. Let's try to submit again. Yep, okay, it works. I'll just start. I'll just click start for that. Okay. Memory is okay. Runtime could definitely get could definitely be better, but we'll keep it at that. Okay, we'll move is subsequence. Okay, given two strings S and T, return true if S is a subsequence of T or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some, can be none of the characters without disturbing the relative positions of the remaining characters. Damn. So what you only need to do here is to keep track of the arrangement um, of these letters. So for example, you have the string S, which is ABC, and T, which is the one you need to find if the S is a subsequence of. So you check A. Once you meet A, that's already a check mark there. You just need to find another B. If you find a B, it's a check mark. C, check, then done. You're done with it technically. Okay. Let's restart it. I forgot to restart it as, or yes, I can, but keep that. So what I want to do is to try and parse the S. Oh, it could be 0. It could be 0. But regardless, um, for I, for letter in S, I need an iterator. I'll just name it count. If oh this oh this can be tricky. Oh wait, I think instead of iterating at S, I iterate at T, and if letters equal to S count, technically this is you checking if that's already covered, right? Then I could definitely just add one. Then would this work? It does work. I'm not so sure if it will work on other inputs, but we'll try. Yeah, okay, okay, okay. You got me there. Too greedy. So count could definitely be pass it if count is equal to len s, then I'll break and just return, right? So wait, for this case, I just need the I'm already here. Let me just use that test case. I forgot to break here. It's really gonna access that. Oh well, what? Let me just try to print count here. What is count doing here? It yeah, it runs 0. Oh, I think that's us just catching that. And this is an okay check. Hopefully this goes through. Okay. There we go. That's fine. It took me 3 minutes, not the worst. Let's reset that. I'll start it on at the next. But the next one would be a medium, so it would definitely take me some time. Oh hell no. It's the container. I even forgot how I did this before. Okay, you're given integer array height of length n. There and vertical lines drawn such as two endpoints of the ith line are I comma 0 and I comma height. The index of that. Find two lines together. You may not slant the okay. Oh, this one's quite difficult, but I forgot how I did this. Um, let's think of our thought process. I'll probably start because we have 2 pointers. I'll probably start at both ends. For example, I start at this and that index. Whatever the smaller one is, I'll move up a bit. So this is the bigger one. I'll move this, the bigger one there, this, move this, move this, move this. Is that enough to iterate through all of it? Hopefully yes, but because if not, then that would not be really ideal. I'll just have a max value here and 2 pointers, right? Left, right. Oh, I can't do that. Land of height minus 1. No. Is height? Yeah, height is actually the list. Okay. So it's just us trying to converge, right? So while left is still less than right. If it becomes equal to right or it is more than right, then it's just gonna exit the while loop. So what we're gonna try to do is to compare which one of these combinations are bigger or smaller. But what we will be doing first is compute the maximum volume that you can get. Current val is just as multiplying the two values. So height left times height right. So if that value is oh wait, you could definitely simplify this as this. So you do of max val and what we've done earlier, height left times height right. This is a more succinct Pythonic syntax, so that should probably help. Then you'll check if height left is greater than height right, I'll just move the right. Right, I'll subtract by 1, else left plus equal to 1. Then it will just do that, and hopefully after iterating through it all, it will be able to get the value, which it did not here. It should be 49, but it didn't get 49. But it should get 49. Because when you iterate through this, what will happen is you move this to this and you'll get 8 and 7. Right? 8 and 7. When you multiply 8 and 7, that's 56. Oh, that is weird actually. How do you multiply stuffs here? Oh, just the... Yeah, it won't be able to handle the bigger stuff. That makes sense. The max of the minimum, would that be an okay case? The minimum of this times 2, or technically just the square of that. Let me see. That might not be the best case. 7749, right? Let me just try to see what the value is here. What time is it? It's 34. Yeah, 7 times 7. That should be a 7 times 7 there. Okay. Wait. It should be a 49. I should be seeing... Oh, there's an 8. I'm actually not doing it correctly. It should be the... Oh yeah, yeah. I get it now. That's how I should do it. It's not as multiplying that value. It should be the width, right? Curve value should be the technically the minimum of these two values. Wait. Times the difference of the right and left pointers. Then I'll put that here. Here we go. I hope I was able to handle most of the edge cases. It does work. Oh my god, we got just in the middle of the distribution. I think that I'll take already. That's pretty good. I was having a hard time before in this kind of problem. That's actually very surprising. 6 minutes? Not too shabby. Okay, let's try to do another one. Okay, this I'll be cooked. There's no way I can do this. Max number of k-sum pairs. You are given an integer array nums and an integer k. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Oh, okay. Wait. I probably could do this. This is like complements. You're trying to get complements, right? And you compute how many operations that you could do. Okay, so you'll definitely be getting the complement most of the time here. Okay. So what I'll be doing is to create, I don't think I need a hash map here. I, you actually just need two pointers here. One on the left and the right, and you just check if you'll be getting the sum of k, right? I'll do another left and right here. 0 and the length of nums minus 1. But you could just do, yeah, you could also do just the complement of it. Like you compute the complement every single time you get the values, and then you remove them. But I think this is a bit more cleaner. So while left is less than right, so your target value would always be k, and you'll just check both of these values. So cur would stand for the current value of the added numbers. So let's say you have nums left, which is 1 plus nums right. In this case is 4. And if cur is equal k, you get to move your pointers both left and right. Right, so just subtract 1. And if cur is less than k, you'll probably just move your left pointer because you need more values to add. And the other case that is just not handled here is when your current sum is larger than k. So that means you need to reduce the bigger number. The thing here is I don't know if it will automatically just converge, if it will just pass on that. But hopefully, I'm just hoping here. Of the operations will be tracked through this. Let's check. Oh my god, what is happening? I'm not sure. I'm sure there's some edge cases that is not handled yet. Yeah, there we go. Okay, I need to sort it. That's one thing that I didn't do. It wasn't sorted. Nums equals to. Oh, you can just do nums sort, right? And it should work. Wait, let me use this test case and run the code. Yeah, should be able to handle it now. There we go. That's actually really good. 91 and 74. Wow, 6 minutes as well. My brain is working tonight. That's really good. Okay. That's already 2. That's already 4, right? Let me just check. Refresh this. So I was able to handle the yeah, that's my account. Yeah, I was able to do it yesterday here. Let me just mark them. I didn't do it here. I'm surprised. I thought I did it here already. That one is kind of... Oh, maybe I could try this one. But that's very difficult though. I got time to practice this one. Oh shit. This is a prefix sum for what I remember. Can I recall it? If I can recall it, I'll be very happy, of course. But if not, I also give myself some leeway. What you want to do here is to multiply the array on the right side, like 1 times 2. So for example, it's gonna be 1, 2, 2 times 3, 6, and 6, 24, right? Then, you need to parse it backwards. So what you want to do is to multiply it again via these numbers for what I can remember. So 24 times 1, right? 24 times 1, 2 times 6, 3 times 2. That's 3 times 2, it isn't 8. So that's not correct. Oh wait. This is there's a way here. I just forgot how to do it. Wait. Um 1, 2, 6, 4. How do you do this again? 24. So 24 is technically the that in itself is already solved, right? So this stands as the product of every single thing except the first index. But this isn't yet because it's lacking the value on the right, which is 4. So I skip this. I multiply this by 4. I multiply this by 3. The ones that you weren't able to add up, right? So what you'll do is 24 is already the value for 1. 6 wasn't multiplied by 4. It's 1. Oh, we're dealing with 2. So what the value that you weren't really able to get is, wait, this one is for value for number 1. This is for value number 2, I'm assuming. This is for 4. You were able to compute everything except for 4. This one, the second value, this is everything except three. So you multiply it by 4. And then the 1 is, again, 24 is for 1. Oh, this is kind of difficult. I'm losing myself in my thoughts. Alright, wait. Sorry. Help me or do you?